Conservative forces. What is a conservative force? A conservative force is a force that conserves energy. Such a force obeys the law of conservation of energy. As the name suggests, to conserve means to protect, right? So the law of conservation of energy states that energy can neither be created nor destroyed, but it can be converted from one form to another. For instance, if we have a particle that moves from point A to point B, whatever path we take, we will only and only see the initial and final position of the particle because irrespective of the path taken, whether long or short, whether rough or smooth, energy will be conserved. There will be no energy loss in case of a conservative force. Examples of a conservative force. We have gravitational force, we have elastic spring force, electric force, magnetic force, etc. In all these forces, since they are conservative forces, so there will be no energy loss irrespective of the path we take, whether it's smooth or whether it's rough. For a force to be a conservative force, it must obey two conditions. These two conditions, they will be explained in the next video, but here we shall only tell you that what are these two conditions. Number one is that the total work done in a closed path should be equal to zero, and number two is that the work done should be independent of the path followed by a body in a closed path. In contrast to conservative forces, we have non-conservative forces. What are non-conservative forces? They are actually dissipative forces. To dissipate basically means to lose energy. These forces, they take energy away from the system as the system progresses. That is, they are path dependent. What do you mean by the word path dependent? It actually means that the path, it decides what kind of force will be executed on the object, whether it will be a large force or whether it will be a small force, whether we will have more energy loss or whether we will have less energy loss. For example, we have frictional force, tension in a cord or tension in a string. We have the normal upward force on any object. We have the propulsion force of a rocket or of a motor. We have air resistance, etc. In all these forces, we have energy losses. For instance, let us consider a frictional force. In a frictional force, what happens is that depending on the path we take, we have energy losses. For instance, if this object is moving through a rough path, so more force will be applied to this object, more frictional force will be applied, and hence more energy losses will occur. However, if the same object moves through a smooth path, then less frictional force will be applied, and hence less energy losses will take place. Therefore, here we have a slight difference between conservative forces and we have non-conservative forces. The first point says that conservative forces, they conserve energy, right? That is, there is no energy loss in conservative forces. However, in non-conservative forces, they dissipate energy. There are many energy losses as we move through the path. The second point is the work done is independent of the path followed. In a conservative force, the work done will be the same whether we take a large path or whether we take a small path, etc. But in a non-conservative force, the work done, it depends on the path followed. That is, if we have a rough path or a smooth path, that's actually the slightest or the most simplest example in these cases, that the work done actually depends on the path followed. Third point, that is, work done in a closed path should be equal to zero in case of a conservative force because there is no energy losses. Hence, the initial work and the final work will be zero. However, in non-conservative forces, the work done in a closed path is not zero. The work done in a closed path is not equal to zero because there are many energy losses, so the final and the initial energy and the final and the initial work should not be equal to zero. The fourth point says that the work done is completely recoverable. Since we've already discussed that conservative forces, they conserve energy and there is no energy loss, so obviously the work done is recoverable. We can actually get back the work done we have already done. Next, we have non-conservative forces. The work done in non-conservative is not recoverable. For example, we have a gravitational force that is a conservative force, and we have a frictional force that is a non-conservative force. That's it for today. Thank you for watching. Do subscribe, like, and share. If you have any queries or any questions, do comment down below.